we go. We're looking at a parallelogram. What is a parallelogram? Where you have two sets of parallel sides, the top and the bottom, and the other two sides, they're parallel. That's a parallelogram. Here's a picture to show you. Remember these little triangle marks? That they mean that they're parallel. So like the little one triangle mark here and here, those two sides are parallel. And you can just kind of tell. So it says opposite sides and opposite angles. These two sides, I don't know if you can see the color, but this one's red and this one's red. It's showing that those are opposite sides. Those are opposite sides. Opposite angles are B and D and A and C. You see how they're kind of across from each other? They're opposite sides and opposite angles. Let's see. The first theorem that it tells us, all right, so basically it's telling you this is true, this is what you're going to use. If we have a parallelogram and you see how they draw that little picture, that's a little parallelogram symbol, ABCD is a parallelogram. Then opposite sides are congruent. That's it. It's kind of like a rectangle. Think of that. Does that make sense? Opposite sides are congruent. Yes, no, it's just that easy. That's our first rule. Opposite sides are congruent. If you have a parallelogram, opposite sides are congruent. Okay? Then it says, it talks about consecutive angles. What does consecutive mean? Because they'll use that word a lot on the ACT. Does it mean? Consecutive numbers. What are consecutive numbers? 3 consecutive odd numbers. Somebody tell me. 1, 3, 5. One after the next. What are 3 consecutive even numbers? 2, 4, 6, 8, 10, 12. Does that make sense? They're going in order. All right? There's one after the next. They're in an order. Anyway, so they use this word consecutive angles. Where is it? Right here. Consecutive angles are going to add to 180. So if it's a parallelogram, consecutive angles are supplementary. A lot of words. But all that means, so this is our second rule. Our first rule, if we have a parallelogram, opposite sides are congruent. Like if this side's 8, what's this side? 8. Okay? They're congruent. Now, consecutive angles, that means angles next to each other, would add up to 180. They use the word supplementary. We know that's add up to 180. Consecutive angles are B and C. See how they're next to each other? Or A and B. Those are consecutive. Or A and D. Or D and C. Right? I could just go all the way around it. But consecutive angles add to 180. Are we ready for our first example? So we've learned 2 rules. Here's our first example. It says, what is angle P? They give us this picture. It's kind of weird. All right. But this is a parallelogram. They tell us, Okay, what are we looking at? We're looking at this little green box. P, Q, R, S. Scoot it over where? That? So do y'all see we're looking at P, Q, R, and S? There's a parallelogram in there. I know that S is 64. What's angle P going to be? What do they add up to? 180. They add up to 180. So you would just do 180 minus 64, and what is that? 116. That's all you're doing. So I would know that P is 116. I would know that Q is 64, and I would know that R is 116. And that's actually something that we're about to learn next. Opposite angles are what? Congruent. Okay? That's the last thing. No, we have another theorem, actually. But, so opposite angles are then congruent. But you would know if this is 64, then that's 116. P is 116. If P is 116, Q has to add up to 180 with it. So what is it going to be? 64. And this one's going to be 116. And you'll see that opposite angles are congruent. Let's see. If S is, let's pretend S is 86. What's Q going to be? 86. What are the other 2 angles going to be?
The other number.
180 minus 86, which is what? 94. So the other 2 angles would be 94. Do we understand that? Let me look at our worksheet and see what Y'all can do the first 6 problems. And all you're going to do is find, for some reason they don't do the sides, the angles. What do we know about consecutive angles? They're going to add up to what? 180. If the angles are across from each other, opposite, then they're going to be equal. Okay, so that's all you're going to do on 1 through 6. Let me pause this.
So we still do 180 minus.
Okay, so y'all done 1 through 6. Now you can, it's the same concept on 17 through 24. I'll actually do a couple of these with you, but so y'all are going to have to write all of them down though. Let me do number 18 with you first. The first thing you should know on number 18 is, what is angle 2 going to be? 112. Okay, so I would write 112, because you know opposite angles are equal. Then how would I find angle 3? 180 minus 112, what's that?
68.
So this is going to be 68, and this one is also going to be 68. Does that make sense, y'all? Now, then we have some where we have all these triangles and things. We know some stuff about triangles, though, right? So we can use some of that. Pick one that y'all want me to do. Do y'all want me to do 22, maybe? 24. Okay. So on 24, if this is 113 and this is 45, how do I find angle 3?
I add those two.
Yeah, they should all add to 180. So whatever 180 minus those two numbers is, and somebody tell me what the measure of angle 3 is.
22.
22. Okay, and y'all, it's just like a little puzzle. What is angle 1 going to be? Y'all should know it already. 113. Very good, because it's opposite. Okay, so this one's going to be 113. Now, there's a little thing you should kind of be able to tell. What is angle 2 going to be? We're just looking at your picture. 45. Because these are alternate interior angles anyway. So we know this one's 45. So we can actually use a lot of rules from before. Go through. Do y'all want me to do one more? Pick one more. 20. Okay. On number 20, if this angle over here is 60, then the angle over here is what? 60. So then I can know angle 1. What's it going to be? Because this plus 60 and 60 should all be 180. So 180 minus 120 is what? 60. So that angle's 60. What do y'all think angle 2 is going to be? 60. There you go. All right. So it's kind of like a little puzzle. You're using things about triangles and parallelograms. You know opposite angles are equal. You know alternate interior angles are equal.
Is that you?
I will tell you on number 2, if you look at number 2, these two angles right here, what are they going to add up to be? Because they make a straight line. 180. So see, these are rules that go all the way back. 180 minus 75 would tell me what angle 2 is. I would know that these are alternate interior angles, so 1 and 3 are going to be equal. What do I know about this angle right here? If this is 75, what's this? 75. See, you can piece things together using vertical angles, all these things that we've learned before.
75.
If this is 75, then this is 75. That's across from it, the vertical angles. Then I would be able to tell what 3 is. And once I can tell what 3 is, I know 1 and 3 are equal. Because they're alternate interior. Uh-huh.
So the one on the one above that, it's 1 and 3 are each on 2.
Yep. Uh-huh. And you know 78, that's vertical angle right here. So you could use that. You know 78 and 2 should add up to 180. So just using the same kind of rules.
So would,
Let me pause
They all
this.
add up to 180.
The next rule says that if you have a parallelogram, okay, then, I already did that. Opposite angles are congruent. All right, never mind. I already did that one. So we can go on to the proof problem. I'll go over number 7 with you. We'll do a proof together. So for the given, are y'all watching? What do I write? Yeah. right, what does that mean? What are they even saying?
They're parallel.
They're saying it's a parallelogram. Yes. Kind of just draw a little crooked rectangle. Okay, so look, on number 7, the first thing it's telling you is that it's a parallelogram. All these rules that we're learning, you have to know for sure it's a parallelogram before you can apply those rules. Opposite sides are congruent only if it's a parallelogram. Opposite angles are congruent only if it's a parallelogram. Have I gone through the diagonals yet?
No.
I think maybe that's what I'm trying to prove. I don't know. Let me see if we know. The next thing is that the diagonal pieces are congruent. I don't know if I need to know that for number 7 or not yet. We'll get to it though. So the first thing I'm going to write though for number 2 is that parallelogram, or it is a parallelogram. EFGH is a parallelogram. And then I would also say EG and FH are diagonals. Diagonals. EG and HF. That's given. Okay, so they are assuming that we know this already, that the diagonals of a parallelogram bisect each other. So if the diagonals of a parallelogram bisect each other, then what am I going to say? EK is equal to what? KG. And what else am I going to say? Yep. KH and FK are equal to each other. That's what it means. If they bisect each other, that they what? They're cut into 2 equal parts. So that's this next rule that we're learning. So I'm going to write that for number 2. It says the diagonals of a parallelogram bisect each other. So I know that EK is congruent to KG. And I know that this little part, HK, is congruent to KF. The diagonals are cut in half, cut into equal parts. So why is EF congruent to GH? Look back at your picture. What was the first rule we learned today? Why is EF congruent to HG?
Because opposite sides are.
Yeah, that's the definition of a parallelogram. Opposite sides are congruent. So, and that's what they say. Opposite sides of parallelogram are congruent. That's why. So, and I'm going to mark that. So I've got this EF and HG are congruent. So look at all my little markings. Now let's go back to see what in the world are we even trying to prove. Read that statement. Prove that what? That those 2 triangles are congruent. So that's what number 4 is going to be. I'm about to state, why are these 2 triangles congruent? Can you look at your picture and tell why are these 2 triangles congruent? This goes all the way back to chapter 3, I think, or 2. Why are those 2 triangles congruent?
Side, side, side.
Very good. Side, side, side. I know that each side matches another. So I know that one was a little bit difficult. I think we have more proofs in the next lesson, which we're not doing today, don't worry. Are y'all ready to move on to the next part? I'm going to give y'all, let me see which ones I want to give y'all.
9 and 11. 9 and 11.
I think I'm going to give y'all, let me pause this and look. Y'all are going to do numbers 8 and 9, and I'm going to do numbers 10 and 11. And these are a little bit difficult. It goes back to remembering some hard stuff from Algebra 1. Okay, but we need the practice of this anyway. So y'all are about to do 8 and 9. I'm going to do 10 and 11. Let me circle all these for them.
Miss Miranda, I really have to go.
Okay. You'll just have to try and get this from somebody. Yeah. All right, so number 10, I'm going to draw the little picture that they have. Let me draw this parallelogram. And what do I know about diagonals now? Yeah, that they're cut into equal parts. I know mine doesn't look like it, but it's supposed to. So it says that this one is 3x. AE is 3x. I'm looking at number 10. Y'all follow along with me. Then it says that EC is 2y minus 2. So I'm going to write that. What do I know about those two things? They're equal. I'll write that in a second. Then they do the other diagonal. This one is 5x. And this one is 2y plus 2. I know that's hard to see on my picture. But I'm going to write those two diagonal equations as equal to each other. So this is not easy. This is something that was difficult back in Algebra 1. 3x equals 2y minus 2. And I'm writing that the 5x equals 2y plus 2. Now, whenever we go to solve equations, this one, do y'all remember all that substitution, elimination, graphing equations, all systems of equations? I couldn't think of what it was called. That's what it was called. So, I was hoping for a substitution problem, but I think number 8 and 9 are better by substitution. This one, I would do elimination. It's where you basically add or subtract equations together. Do y'all remember that?
I remember that.
Do y'all see how we have something that matches? What does this one have? A 2y. What does this one have? 2y. So on this one, it's going to be an elimination. I'm going to stack those two equations together. 2y minus 2. Since they're written the same, I'm just going to go ahead and write them like that. Now, would I add or subtract them to make the 2y's go away? If I add them, what's 2y plus 2y? 4y. Did that go away? No. But if I subtract, what's 2y minus 2y? Nothing. That's what I need to do. So let me subtract the entire equation. What's 3x minus 5x? Negative 2x. Y'all already said that my y's are going to go away. And what's negative 2 minus a 2? Negative 4. Then what am I going to do to solve for x? Divide by negative 2. So what is x going to equal? X equals 2. All right, and that's the first part. It says, the whole problem says, what are x and y? So I found x. How do I find out what y is going to be? Just go back and plug in my x and see what's left over. Does that make sense? X is 2, so what could I write right here? Instead of 5 times x, what would I write? 10. 5 times 2 is 10 equals 2y plus 2. How do I find out what y is? Subtract 2. I get 8 is 2y, then what? Divide by 2, and I get that y is 4. So see, we're having to put these equations together and solve. 8 and 9 are done a little bit.
Number 10?
That's number 10, yeah. What I should have done is given y'all, well, I'll just do I'm going to do number 11. I was going to say I should have given y'all 11, but I'll do 11, and I think that'll help you for 8 and 9. That one was elimination. Now, on number 11, I'm doing the same thing. I'm setting my AE and my EC equal. That's 2x equals y plus 4. And then my other one, oh, y'all can't see that. My other one says that x equals 2y minus 1. Well, on this one, we're going to use substitution. So, when you have a variable by itself, what does x equal? Read that second equation. Tell me, x equals what? Read that. What does x equal? 2y minus 1. Does everybody see that? This right here is what x equals. So guess what I'm going to put in the other equation? Instead of x, I'm going to write what? 2y minus 1. because that's what it is. So this is substitution. So I'm going to say 2 times 2y minus 1 equals y plus 4. Do y'all see that all I did was I plugged that in for x? I just replaced it. So what do I do with that 2? Distribute it. So I get 4y minus 2 equals y plus 4. Now, I need to move my y over. Bless you. So I'm going to subtract y. What's 4y minus y?
3.
So I get 3y minus 2 equals 4. Then what? Add 2. So 3y equals 6. What is y going to equal?
2.
Divide by 3, and y is 2.
So y equals 2, x equals 2y minus 1.
Yeah, and so I can find out what x is. It's 2 times 2 minus 1. What is 2 times 2 minus 1?
3.
Yeah, 4 minus 1 is 3. So x is 3.
So do you do that like if it's like y?
So anytime, which is really on your 8 and your 9, this is what you're going to do, is substitution. I think it's a little bit easier. Actually, I don't know if it's easier than elimination. But this is what you're going to do on 8 and 9. So y'all just try those two. You're setting equal and solving for your x and your y.
13 again?
Is like what's on the back. Yeah, starting at 13. Here's our last little rule for the day. Yay. Okay. And it's really an easy concept. Okay, kind of looks like a ladder, but it just says that if you have 3 or more parallel lines, you see how I have all these parallel lines, A, C, and E? All right, I have parallel lines, and they're cut by congruent segments on a transversal, then any transversal that cuts through is going to have congruent parts. Okay, so let me reword that in English for y'all. It just says that if I have these parallel lines, what? Okay, thank you. If I know that these two pieces are equal, AC and CE, then I would also know that BD and DF are equal. Okay, they may not be like this could be 3 and this is 3. Well, if this one's 4, then what's this one going to be? 4. It's just saying that it's congruent pieces. Okay, that's all it is. Yes, no, kind of like a ladder, right? It would be kind of like a ladder. Ooh, somebody signed up to work. Okay. For instance, let's look at this problem right here. They tell me that these are 1, 2, 3, 4 parallel lines. Do y'all see that? My 4 parallel lines. And it tells me that AB, that this is 2, that this is 2, and that this length is 2. All right? Does everybody understand that? If all those lengths are equal, what do I know about this length and this length and this length? Those 3 lengths are equal. So then it tells me that EF is 2.25. So what's FG?
2.25.
And what's GH? 2.25. Or it may word it different and say, hey, what's the length of EH? Well, how would you find that out? 2.25 plus 2.25 plus 2.25. Okay, it might just word it different. Does that make sense, y'all? I mean, it's just that basic of a concept. So you're going to do 13, 14, and 15. And they just want you to find each length. They say that TU is equal to UV. Well, guess what numbers you're using? These numbers right here. See those two numbers, the 4.5 and the 3.8? That's what you're going to find. Like, what is NM going to be? That's that easy, 4.5. Okay? And then, well, you're going to do 14, 15. You're going to do 13, 14, 15, and 16.
I know, but do we have to do 25?
No, we're not going to do 25. I think we're doing more proofs in the next class.
So for QS, we do
7.6.
For QS, you're going to have to add 3.8 and 3.8.